So today we're going to cover Chapter 11, Section 3. Today we're going to be covering area of polygons. Now you've already seen a bunch of area formulas already. You saw the area of a circle, which you just quizzed on. That was pi r squared. We've worked with triangles. That's base times height divided by 2, or 1/2 base times height. We've also seen squares and rectangles, where a square could just be side to the second power, or base times height, or length times width, which is the same as a rectangle. So on the very first slide here, we have the formula for area of a rhombus or area of a kite. So the area of a rhombus or a kite, when you're given the length of the diagonals, is just 1/2 diagonal 1 times diagonal 2. So if you think about it, the way that they came up with this formula, it's like dividing it into two congruent triangles with a base of the first diagonal and a height of the half of the height of the second one. You don't need to know how it's figured out. However, if you are not given a diagonal, you would have to separate it into some triangles, and then potentially it could be a special right triangle, especially if the rhombus has 90 degrees, which would really make it a square. But you're just basically memorizing that the formula for area of a rhombus and a kite is 1/2 diagonal 1 times diagonal 2. If you'd rather do diagonal 1 times diagonal 2 and then divide it by 2, you can do that. Either way. The next slide has two examples. So notice that they're giving us the lengths of the diagonals outside. So this diagonal right here is 6 meters long. This one is 8 meters long. So in order to find the area of that rhombus, and I can tell it's a rhombus because it has 4 congruent sides, I'm just going to do diagonal 1 times diagonal 2 and either divide it by 2 or multiply it by 1/2. So either one. This will be the formula for a kite as well. So my diagonal 1, it doesn't matter which one is which. I could say this one's diagonal 1, this one's diagonal 2. It really doesn't matter because multiplication is commutative. So 8 times 6 is 48. Divide that by 2, and it's 24 meters squared. That would be the area of that rhombus. Then for the kite, exactly the same thing. So I have this diagonal here is going to be the 7, and then this one is the 10. And again, I could say this one is D1, this one's D2. Really doesn't matter. You're just going to multiply them. So area is equal to 7 times 10. And you could also multiply it by 1/2. It really doesn't matter. So 1/2 of 7 times 10, 7 times 10 is 70, and then 1/2 of that is 35, and these were centimeters. Again, if you'd rather do 7 times 10 divided by 2, that works as well. Okay, before we move on, we need to identify some parts of a regular polygon. So the center, that definition is going to be the center of the circumscribed circle. So on all of these polygons, you could draw a circle around the polygon, and then that would be your circumscribed circle. The radius is just going to be the radius of the circumscribed circle. It's also going to be the distance from the center to a vertex of the polygon. Notice in my picture down at the bottom, the red lines are the radiuses or the radii. So in the picture down there, the radii are all drawn in red. And then a central angle is going to be an angle that is formed by 2 radii that are drawn to consecutive vertices. So in my picture here, my central angle, go ahead and do that in purple here. My central angle could be right here. And notice the 2 consecutive vertices are M and N. So it's formed by these two radiuses or two radii. So the central angle is, I just put that in purple. And then the apothem, this is a new vocab for us. It's going to be the perpendicular distance from the center of the polygon to a side. So in my picture here, the apothem is in blue. So it's this blue segment going down here. Notice it's a distance because of the little right angle. So remember, the apothem goes from the center to a side. It's not going all the way to the edge of the circle. The radius is always going to be longer than the apothem because the radius goes all the way to the circle. Also, one thing to remember is all central angles are always going to be adding up to be 360 degrees. This knowledge is going to help us to find the measure of a central angle, because in my picture here, I could draw in the rest of the radii. And again, I could draw one here, 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 and here. And then notice I've got 6 central angles in this picture. Okay, so the formula to calculate the measure of a central angle is you take 360 degrees and then you divide it by the number of sides. Your knowledge of the names of the polygon is going to come back. So remember, when it's a 3-sided figure, it's a triangle. 4 is a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 heptagon. 8 octagon. 9 nonagon. 10 is a decagon. So let's take, for example, a hexagon. Here, as soon as I tell you that you have a hexagon, you need to know that the number of sides in a hexagon is going to be 6. So your n value is 6. So you would do 360 divided by 6, and the measure of each one of the 6 central angles will be 60 degrees. Let's say we have a square. We know that a square, the number of sides is 4. So if I do 360 divided by 4, each central angle is going to be 90 degrees. So here's where knowing the names of the polygon and knowing how many sides are in each is going to help us. All right, so example 2, they're giving us the diagram W, X, Y, Z, and they're telling us that this is a square that is inscribed in circle P. It wants us to first identify the center. So the center of this circle, again, remember when you name the center, you use the center point. So the center point is P because they told us it was circle P. Then they want us to name the radius. So I have a radius. They've actually drawn 2 in here for me. So my radius has a length of, or I'm going to name it with 2 letters. The radius is either PX or PY. Now you could also name the radius XP or YP. The order doesn't matter. The next thing they want us to name is the apothem. And remember, the apothem is that perpendicular distance from the center to the side of the polygon. So my apothem is right here, it's PQ. And then they want me to also name a central angle of the polygon. that one in pink. So I have a central angle. There's actually two that I could name here. Actually, only one, because they don't have any other radii drawn in here. So my central angle is going to be angle XPY. You could also name it YPX. So this is one central angle that's already drawn in here. And it's that angle there with its vertex at the center. Next, they want us to find the measure of XPY, XPQ, and PXQ. So let me identify where XPY is. So XPY is the central angle. And remember, the formula to find the measure of a central angle is 360 divided by the number of sides. So XPY is 90 degrees. Then the next one they want us to find is the measure of XPQ. Let me go ahead and get another color here. Let's do gold. XPQ is this angle here. And notice for XPQ, once you draw in the apothem, this central angle is going to be bisected. So this is going to be 45 degrees. And then lastly, PXQ. So if you think about this, let me go ahead and pull this little triangle out of here. So if I take this that I'm highlighting in pink, draw the purple side, and then my radius. And remember, this was a right angle here. This angle we just found to be 45. So this would turn into our special right triangle. So then this angle now, PXQ, is also 45 degrees. Because if you add up the two sides you already had, the 90 and the 45, 135, subtract it, you get 45. But again, as soon as you see it's a right triangle and one of your angles is going to be 45, then the other one will also be 45. Thank you. So it says the area of a regular n-gon with the side length of S is equal to 1/2 the product of the apothem and the perimeter. So where A in this formula represents the apothem and the capital P represents the perimeter, that's how we're going to get the area of a regular polygon. Remember, the word regular in front of a polygon name means all angles and all sides are the same. Now, another variation of this formula is 1/2 ANS. Because if you think about it, when you're calculating perimeter, what you're doing is you're finding the length of one of the sides and you're multiplying it by the number of sides. So that formula for perimeter is really number of sides times side length. So P is equal to NS. So the reason why they're giving us two different formulas is if they've already given you the perimeter calculated, then all you have to do is multiply it by the apothem and then by 1/2 or divide it by 2. If they've given you the name of the polygon, the side length, and the apothem, then you could use the bottom formula. Remember, both of these formulas could also be divided by 2. So ANS divide by 2, or apothem times perimeter divide by 2. So timesing it by 1/2 is the same as dividing by 2. So the first example tells us that we have a regular hexagon with an apothem length of 6. So when we go to do these polygon areas, what we need to figure out is the n value, and we get that from the name. My n is my number of sides, so you need to know that a hexagon has 6 sides. You also need to know the apothem length, and this time they gave it to us. And then we also need the length of the side, which we don't have. Because remember, the formula we're using here is either 1/2 apothem times perimeter, or 1/2 apothem times number of sides times the side length. I have everything except for the S. So that's what I need to work on finding. So I'm going to go ahead and draw a picture of a hexagon. Again, it doesn't have to be perfect. I'm going to just put 6 dots around. And again, the word regular means that all these sides are supposed to be the same size. So this is my hexagon. It has 6 sides. I'm going to go ahead and you could draw the circle around it. Just know that this hexagon is circumscribed around a circle. So if you wanted to draw the circle around it, you can. We really don't need it. But I'm going to draw in my 2 radiuses, or my radii, to form my central angle. So the blue are my radii. Now I need to find the measure of this central angle here. So I'm going to take 360, divide it by the number of sides, which is 6, and I get 60 degrees. So the measure of my central angle here, up at the tippy top, is 60 degrees. I'm going to pull this triangle out. So right now, I have a 60-degree angle up here. I need to draw in my apothem. So my apothem, I can draw down in here. Notice the apothem is going to bisect that angle. Because if you think about it, right now this is an isosceles triangle. Because the sides that are forming that central angle are radiuses, or radii, and they're congruent. So whenever you draw in the altitude, or that apothem, it bisects that angle. So now what I'm going to do is focus on this side of this triangle. And I'm going to turn it into a special right triangle. So I've got my apothem I drew in. I've got my radius, and then I've got half of the side length. Now they told me the apothem length, it was 6. Now, remember, this 60-degree angle up there at the top was bisected. So this is now 30, and then this is 60. So now you're going to bring back your knowledge of special right triangles. Now, when we did this in the special right triangle lesson, I used the variable a. I'm going to use the variable x so I don't confuse it with my a, which represents my apothem. So across from 30 will be x, across from the hypotenuse is 2x, and across from the 60 is going to be x square root 3. I need to find the value of x because that's going to give me half of my side length. So what I'm going to do is solve the equation. X square root 3 equals 6. Going to divide by the square root of 3. And x is equal to 6 over the square root of 3. I need to rationalize. And I get 6 square root 3 over 3. This will simplify. I can divide the 3 and the 6. And then this becomes 2 square root 3. So now that is this. This is what I needed. I needed to find the side length. So this little piece here is 2 square root 3, and so is this one. I'm going to add them to get the length of the side of my hexagon. So 2 plus 2 is 4. So each one of the sides of my hexagon is 4 square root 3. Now I have the value of the 3 variables, and I can now plug them in to this formula. So now I'm going to find the area of my hexagon, 1/2 ANS. The A was given to me from the beginning. It was 6. The N was given to me from the beginning. It's a hexagon, so it's 6. And then now my side length is going to be 4 square root 3. So now I'm going to multiply these 3 together. Once I multiply, again, you could take half of 6, make it 3. And now I'm going to multiply 3 times 6 times 4. 3 times 6 is 18 times 4, 72 square root 3. And notice there were no units given on this, so I'm just going to say units squared. Pretty good there. Now, if it would have asked for the perimeter as well, remember perimeter is equal to the number of sides times the side length. So you could actually have done this ahead of time and do 6 times 4 square root 3 and then get 24 square root 3. So then instead of using this formula, you could also do area is equal to 1/2 apothem times perimeter. And again, my apothem was 6. And then perimeter, 24 square root 3. Either way, you're still getting the same answer here. So then here we would just multiply. I could simplify this, make this a 3. And I still get 72 square root 3. And again, units squared. For the next one, again, what I would always do is quickly write down N, A, and S, and then I would go ahead and fill in and see if you already have the value of the 3 variables. If you do, then you don't need to worry about drawing anything. So the number of sides, my N value, it's an octagon, so it's 8. They gave me my apothem, it's 3. And they gave me the side length, it's 5. So again, we can just now, if they want us to find perimeter first, it's the number of sides times the side length. Number of sides is 8 times the side length is 5. And I get 40 units. That's the perimeter. For the area, since we've already calculated the perimeter, we can use the 1/2 AP formula. Now, again, remember, you can also do 1/2 ANS if they don't ask you to do the perimeter ahead of time. So if I fill this in, 1/2, my apothem is 3. I just found the perimeter to be 40. And you can simplify it before you multiply, but you guys are using calculators. So then this would become a 20, and then the area will be 60 units squared. If you did it over here by not calculating the perimeter ahead of time, you would do 3 times 8 times 5, and then divide it by 2 or multiply by 1/2, and you still get 60. So when you're starting out by being given everything, you're just plugging it into the formula. The easiest way to draw these polygons is I would just, like, for example, if you had to draw an octagon, I would just take 8, start putting 8 dots around the edge here, and then draw your octagon. Again, I'm not looking for precision. And then you could draw an octagon this way. And then your central angle, remember, is formed by 2 radii. And again, you could always take that, if you had to find that central angle, you would take 360 and divide it by 8, and then you could get the measure of that central angle. If you were not given everything, then this is where we're going to bring back our SOHCAHTOA and use our trig. But in this particular problem, they gave us everything we needed. So all we had to do was plug it into the formula. All right, next we're going to be working with an equilateral triangle. Again, I would go ahead and write down the three variables. The n, it's a triangle, so it's 3. They gave us the apothem, it's 8. I need to find the side length. So let me go ahead and draw an equilateral triangle. All right, so there's my equilateral triangle. So again, remember when it's equilateral, all the sides are going to be the same. So generally when it's a triangle, they may not use the word regular in front, but you may see that. But generally they'll use the word equilateral. So let me go ahead and add in my center point. Again, you could draw the circle around it if you want to see it, so you can draw in the radii. So here is my circle. And again, we could draw in the radius lengths because they form the central angle. I need to find the measure of this central angle by taking 360, dividing it by the number of sides, and I get 120. So 120 is the measure of this central angle. I'm going to pull that central angle out of there along with the side of the triangle. I'm going to draw in my apothem. So my apothem goes straight down and it's going to bisect that 120. So then I know that this is 60 and this side's 60. And again, I'm only going to focus on this one side, my special right triangle. So let me go ahead and draw this in here. So I've got my 30, 60, 90 triangle again. So remember, this is x, this is x square root 3, and this is 2x. Remember, what we're looking for is the side length. And that side length is going to be this x square root 3 times 2. They gave me the apothem. My apothem length from the beginning was 8. It's right here. So this x value is 8. So then this will be 8 square root 3. And if I needed the length of the radius, I would put a 8 there, and it's 16. Now remember, this 8 square root 3 is for this side and this side, which is over here, the side of my triangle. So I need to add those two together. So 8 square root 3 plus 8 square root 3 is 16 square root 3. This is the length of the side of my triangle. Now that I have the value of the three variables, I can plug them into the formulas. And I'm going to leave it in simplest radical form. So let's say they asked me to find the perimeter, number of sides in my polygon times the side length. Number of sides in a triangle is 3. I just found the side length of the triangle to be 16 square root 3. I'm going to multiply. Remember, you multiply outside by outside, so just 3 times 16. And the perimeter is 48 square root 3. And notice they didn't have any kind of units on it, so it's just units. Now to find the area. Now that I have the perimeter, I can just use the formula 1/2 AP. So again, plug in. My apothem was 8. My perimeter is 48 square root 3. Again, I could take half of 8, make this a 4, and now just multiply 4 times 48, and you get 192 square root 3 units squared. Again, you're going to be leaving it in simplest radical form whenever you're able to use the special right triangles. Now, if they say round to a specific place, so for example, if you multiply on the perimeter here, if you were to multiply 48 times the square root of 3, you would get 83.138. So rounded to the hundreds place, 83.14. And again, these would be units. So if it asks for exact, I want simplest radical form. Or if it said leave in simplest radical form, that would be the wording as well. If this one you had to use your calculator, do 192 times the square root of 3. This would give me, so this would give me 332.553, so 0.55. So if it says round to the hundreds place, then you use your calculator. However, on some of the questions on the test, it will be left in simplest radical form. So for example, if I give you a hexagon or a triangle or a square, I would expect you to leave it in simplest radical form. Same thing on the next one. We're going to do a hexagon, and then we'll do a square, and then we'll do some trig. So again, my advice to you is quickly write down N, it's 6. I don't know the A this time, but this time I know the side length. So again, if it helps you to draw a hexagon, go ahead and put 6 dots around the side. You guys are a notability, so it might make a nicer hexagon than what I'm doing. So here's my hexagon. I'm going to add in the center point, because again, remember, this guy is circumscribed around a circle, and to form the central angle, you need to draw in 2 radii into 2 consecutive vertices. I'm now going to take 360, divide it by 6, because that's how many sides are in a hexagon, and the measure of my central angle here is 60. I'm going to go ahead and pull this triangle out and show how it turns into a special right triangle. So here are my 2 radii. These are congruent. Got the side of my hexagon. I'm going to draw in the apothem. It bisects at 60. So now this is 30 and 30. Again, I'm only going to focus on part of it. So I'm going to go ahead and pull it out. So I've got the apothem, the radius, and then half of my side. So this is 30, 60, and the right angle. So this is x. This is x square root 3 and 2x. Again, remember this time we knew the side length. The side of this whole thing is actually 12. So it's bisected. So this tells me that this 12 is now 6 and 6. So x equals 6. So my apothem is going to be 6 square root 3. So now I have the apothem, and now I can plug it into the formula. So again, for part D, if they ask you to do perimeter, number of sides times the side length. Hexagon, it has 6 sides. Side length was 12. My perimeter is 72 units. The area, now that I've calculated perimeter, 1/2 apothem times perimeter. My apothem, 6 square root 3. Perimeter, 72. So again, you can take half of either one of the numbers. Doesn't matter. If you want to take half of 72, make it 36, you can. And then 36 times 6, 216 square root 3 units squared. It said to round to the hundreds place. 216 times the square root of 3, 374.12, because it's 122 units squared. So that's part D. Now let me do part E. Everybody good? So for part E, this is a square. We draw a square. Here's my square. Remember, all sides are the same when it's a square. I can go ahead and add in my center point, draw in my central angle here. Remember, you would take 360, divide it by 4, and the measure of this central angle is going to be 90. Once I draw in the apothem, it's going to bisect that. So now my apothem bisects it. So this is 45 and 45. So these two sides are the same. And in this particular question, they gave me the diagonal length. And if you remember back to your quadrilateral chapter, the diagonals of a square are bisected because it's a parallelogram. So if this whole diagonal is 10, this piece is 5 and this piece is 5. So my hypotenuse here is 5. Doesn't matter which way I draw the diagonal. So now, remember in the 45, 45, this could be x, x, and this side is x square root 2. I need to solve for x. So x square root 2 equals 5. Divide by square root 2. X is equal to 5 over the square root of 2. Rationalize. 5 square root 2 over 2 is going to be part of the side of my square. Because remember, what's happened here is this side is 5 square root 2, and this little piece over here is 5 square root 2. I need to add these. Once I add these, I end up getting 10 square root 2 over 2, which simplifies to 5 square root 2. So my side length of my square is 5 square root 2. My apothem is going to be the x value, and it's the 5 square root 2 over 2. Because remember, this x and this x are the same. And then the number of sides is 4. So now that I found all this, and I'm going to show you another way to do this as well. Let me go ahead and do perimeter first. Number of sides times the side length. So 4 times 5 square root 2. And I get 20 square root 2 for the perimeter. My area, 1/2 apothem times perimeter. So 1/2 5 square root 2 over 2 times 20 square root 2. Once I do all this, if you want to simplify before you multiply, the half and the, actually no, let me fix that. I can simplify the 20 and the 2, make that a 10 and a 1. And then I could also go back and do this and make it a 5. And then remember, when you multiply, so now what I have is 5 square root 2 times 5 square root 2. Notice the pair of square root 2's come out. And then I do the 5 times 5. And the area is 50 units squared. Now, let me show you how we could have simplified this. If you remember back to middle school, remember the area of a square is really side to the second power. So really, once I found the side length, you still had to go through the special right triangle. You could have just done 5 square root 2 squared, and then it would have turned into what we had down there at the bottom. You multiply the 5's, get 25. The pair of square root 2's become a 2, and you could also have gotten 50 units squared. Another way to do this is if you realize that all squares or rhombuses, then you could have also done the formula we learned on the very first slide, and you could have done diagonal 1 times diagonal 2 divide by 2. Because remember, all squares are rectangles, and the diagonals of a rectangle and a square are congruent. So if they gave you one of the diagonals, you could have also done 10 times 10 divide by 2, 100 divide by 2, and got 50 that way as well. So when it's a square, you've got just multiple ways that you could have done these. Now the last two examples, we will not do special right triangles. We're going to need our calculator, and we're going to do SOHCAHTOA. All right, go. Now we're going to do a pentagon and an octagon. When it's a pentagon and an octagon, once we find the measure of that central angle, it will not form a special right triangle. So when we have a pentagon, let me go ahead and draw one. I'm going to put 5 dots around the sides here. Here's my pentagon. Draw in my center point. Draw in my 2 radii. So I'm going to take 360 divided by 5, and I get 72. So the measure of this central angle is 72 degrees. Once I draw in the apothem and I bisect that, what I end up getting is 36 degrees up here at the top. This is not a special right triangle. So this is why we're going to use our SOHCAHTOA. So now let's go ahead. We're going to still do the same thing. Number of sides is 5. They gave me the radius length. So that's not going to help me with my apothem or my side length. It'll help me fill in my triangle. So this is an 8 here. So because it's not a special right triangle, we're going to do trig. And we're going to label the sides based off of the 36-degree angle. So this is going to be opposite, this is hypotenuse, and this is adjacent. So what I'm going to do, my adjacent, this is actually going to be my apothem. So I could call this A, and I could call opposite X. So what I'm going to do is to find the apothem first. I need to figure out which one uses adjacent and hypotenuse. So if you do your SOHCAHTOA, the one that uses adjacent and hypotenuse is going to be CA. So we're going to be doing cosine of 36 is equal to A over 8. So we're going to solve this by multiplying both sides by 8. So you're going to multiply 8 times the cosine of 36. Once we do that, and make sure your calculator is in degrees. So cosine of 36 times 8 gives me 6.47. So I'm going to round it to 6.5. So that's my apothem. I now need to find the side length, which is what I called, half of it is x. So again, opposite now. So now I'm going to do opposite and hypotenuse. So that'll be sine of 36, x over 8. Multiply both sides by 8. So on your calculator, do the sine of 36, multiply it by 8, round to the tens place, and you're going to get x is 4.7. Now remember, that's only half of the side. So either add it or times it by 2. And once you do that and you multiply it by 2, you're going to get your side length to be 9.4. So my side length now is 9.4. So now I can plug it into the formula. If they wanted perimeter, number of sides times the side length. So 5 times 9.4, and I get 47, and these are units. And then for area, the 1/2 apothem times perimeter. My apothem had a length of 6.5, and my perimeter was going to be 47. So I'm going to multiply those three numbers. So 6.5 times 47, and then I could just divide it by 2, 152.75. So if it says hundreds, you'd leave it like that. But if it said tens place, 152.8 units squared. Octagon. So number of sides is 8. Side length is 10. I don't know the apothem. So I'm going to go ahead and draw my octagon. I'm going to put 8 little dots around here, around the sides. So here is my octagon. I'm going to draw in my 2 radii. I'm going to take 360, divide it by 8. Once I do that, I get 45. Now remember, that 45 needs to get bisected. So right now, this is 45 here, but when I draw in the apothem, the angle here becomes 22.5. So now here's my triangle. And I'm trying to find this side. I'm going to call that A. That's my apothem. That's what I'm looking for. So what they gave me was the side length. So when I draw the apothem in, that side length got bisected. So this is 5. So this is opposite to the 22.5. This is adjacent. I'm going to be doing tangent. So tangent of 22.5 is equal to TOA. So opposite over adjacent. Remember, when the variable's in the bottom, you're dividing to solve. So I'm going to take 5 and divide it by the tangent of 22.5. Divide both sides by tangent of 22.5. And A is equal to, once I divide that, 12.1. So now perimeter, number of sides times the side length. It was an octagon, 8 times 10, and I get 80 units. And then area, 1/2 apothem times perimeter. To find the area, you're going to multiply 1/2 apothem times perimeter, and you get 484 units squared.